Let us now discuss on understanding foundations used in construction. So this is a continued discussion for foundation engineering and retaining walls. First, we have to know the two classifications of foundations, and these are shallow foundations and deep foundations. Now we have to know what are the types of foundations. So under each of the classification of foundation, there are several types that belongs to each classification. And for shallow foundations, these are individual footing or isolated footing, and then combined footing, then strip footing or strip foundation, and then raft or mat foundation. And for deep foundations, we have two types, and these are pile foundation and drilled shafts or risons. Now we have to talk each of the types of foundations. First, we're going to talk about individual footing or isolated footing. So, individual footing or an isolated footing is the most common type of foundation used for building construction. This foundation is constructed for a single column and also called pad foundation. The shape of individual footing is square or rectangle and is used when loads from the structure are carried by the columns. Size is calculated based on the load on the column and the safe bearing capacity of soil. Rectangular isolated footing is selected when foundation experiences moments due to the eccentricity of loads or due to horizontal footings. As what you can see here, this is in the form of a rectangle. And this is mainly because during the computation, moments due to eccentricity um, are found. Now, let's talk on combined footing. So combined footing is constructed when two or more columns are close enough and their, their isolated footings overlap each other. And this isolated. So if you are designing footings considering first as an isolated one. However, if it overlaps, then that is the time when you are going to decide and make it as a combined footing. It is a combination of isolated footings, but their structural design differs. The shape of this footing is a rectangle and is used when loads from the structure are carried by the columns. Now we will talk on strip footing or strip foundation. So strip foundation is also referred to as spread footing or wall footing. Wall footing is if especially you are using strip foundation um, in a firewall. As what you can see here, it no longer looks like isolated, and it is shown in strips. So this kind of footing has a base wider than a typical load-bearing wall foundation. The wider base of this footing type spreads the weight of the building structure over more area and provides better stability. Spread footings and wall footings are used for individual columns, walls, and bridge piers, where the bearing of soil layer is within 3 meters or 10 feet from the ground surface. Soil bearing capacity must be sufficient to support the weight of the structure over the base area of the structure. And this should not be used on soils where there is any possibility of a ground flow of water above the bearing layer of soil, which may result in scar or liquefaction. Now, let us proceed on raft or mat foundation. As what you can see here, this is no longer isolated, but it is presented in raft or mat foundation. So these are the types of foundation which are spread across the entire area of the building to support heavy structural loads from columns to walls. That is why most um, like malls are using mat or raft foundation because the structural load of this kind of structure needs to be supported by the column entirely crossing the entire floor area. The use of mat foundation is for columns and walls foundation where the loads from the structure on columns and walls are very high. This is used to prevent differential settlement of individual footings. Thus, designed as a single mat or combined footing of all the load-bearing elements of the structure. It is suitable for expansive soils whose bearing capacity is less for the suitability of spread footings and wall footings. Raft foundation is economical actually when one half area of the structure is covered with individual footings and wall footings are provided. These foundations should not be used where the groundwater table is above the bearing surface of the soil. The use of foundation in such conditions may lead to scar and liquefaction. Now we will talk about deep foundations. The first one, which is pile foundation. So, pile foundation is a type of deep foundation which is used to transfer heavy loads from the structure to a hard rock strata much deeper below the ground level. As what you can see in the image here, these are the piles used as foundation of this house. So this you can see here that it is situated very like deep down the ground, unlike the basic footings or the basic shallow foundations. So pile foundation are used to transfer heavy loads of structures through columns to hard soil strata, which is much below ground level, where shallow foundations such as spread footings and mat footings cannot be used. This is also used to prevent uplift of the structure due to lateral loads such as earthquake and wind forces. Pile foundations are generally used for soils where soil conditions near the ground surface are not suitable for heavy loads. The depth of hard rock strata may be 5 meters to 50 meters. So imagine 5 meters to 50 meters or 15 feet to 150 feet deep from the ground surface. So this is really very deep. It resists the loads from the structure by skin friction by end bearing. The use of pile foundations also prevents differential settlement of foundations. Then we will now talk about drilled shafts or caissons. So drilled shafts, or also called caissons, is a type of deep foundation and has an action similar to pile foundations discussed above, but are highly capacity cast in situ foundations. It resists loads from structure through shaft resistance to resistance and or combination of both of these. The construction of drilled shafts or caissons are done through an auger. So this is a sample image of an auger. An auger is a tool with a helical bit for boring holes. Drilled shafts can transfer column loads larger than pile foundations. It is where the depth of hard strata below ground level is located within 10 meters to 100 meters or 25 feet to 300 feet deep. So usually structures constructed in, for example, reclaimed area are using drill shafts or caissons or structures constructed in an ocean. So basically, they are using this kind of foundation. So this is not suitable actually when deep deposits of soft clays and loose soil where bearing granular soil exist. It is also not suitable for soils where caving formations are difficult to stabilize. Soils made of boulders and an artesian aquifer exist because this kind of soil formation will be if this kind of foundation will be constructed on this the soil formation as mentioned earlier, like in a caving formation or made of boulders or an artesian aquifer where water sources came from, then um, the purpose of drilling shafts that will no longer work. Now, since we have covered the two classification of foundation and each type and the type of each classification, it's time for us to have a recap. What are broad classifications of foundation? So basically, these are shallow foundation and deep foundation. Next, what are the types of foundation? So the we have two classification, shallow foundation, and under this are individual footing or isolated footing, combined footing, strip foundation, and raft or mat foundation. And in deep foundations, we have pile foundation and drilled shafts or caisson. Now, what are the Now, is the difference between pile foundation and drilled shafts. So, drilled shafts has an action similar to pile foundations but are highly capacity cast in situ foundations, where it can transfer column loads larger than pile foundations. It is used where the depth of hard strata below the ground level is located within 10 meters to 100 meters or 25 feet to 300 feet. So it simply means that drilled shafts are deeper compared to pile foundation, and the soil deal with drilled shafts are harder compared than pile foundation because drilled shafts are already using the auger tool or the tool with the helical bit to bore holes. Now, what is the difference between isolated and combined footing? So, combined footing is constructed when two or more columns are close enough under isolated and the isolated footings overlap each other. So it is a combination of isolated footings, but the structural design differs. Last question is, when is raft or mat foundations used? So the use of raft or mat foundation is for columns and walls foundations where the loads of the structure on columns and walls are very high. Rafts are used to prevent differential settlement of individual footings, thus designed as combined footing of all load-bearing elements of the structure. So that is all for the discussion on understanding foundations used in construction. You may check on our next topics. Thank you.